Okay, I'm going to do a short video on this idea of preparing for Chapter 7, IRADS and TRADS. And the first few questions here deal with examples of a stable process. So if we look at this for a second and come over here to section 7.1, the first section of the chapter gives examples of stable and unstable processes with and without variability. So if you look at each one of these cases and try to understand what the difference is between these cases in terms of stability of the process and variability, then you should be prepared for these questions. The next bullet here is what happens to in-buffer inventory and flow time when a process is at 100% utilization and there is variability in either the arrival process or the processing time. So that's going to be section 7.2. And what we're after here is what is this relationship? There's a case 5 and a case 6 here. Here is the situation where there's 100% utilization and there's variability. Guess what happens to the in-buffer inventory in that situation, as this graph shows, right? Guess what also happens to the processing times? There is a very close correlation between the in-buffer inventory and the flow times in this kind of scenario. So you want to read up more about that, understand some of the more details about that for section 2. What's the main reason for having safety capacity? This talks about safety capacity farther down here. Safety capacity as a concept is here. Safety capacity creates stability. And this section here talks about the main reason for having safety capacity. And you can see here the difference for this same case 6 with safety capacity of just 1. All of a sudden this is a stable system. Even though a Q does go up to, what's that, 23 looks like, it is a stable system. Next bullet, what are the 6 parts of the Kendall notation for queuing systems? This is from the 1953 Kendall notation, and this is in section 7.4.7. And there's 6 parts. And so this question deals with what are those 6 parts? So if we go to 7.4.7, let me bring that up here. This is the notation. And 7.4 goes through all of the elements here individually, and then 7.4.7 puts them all together into this notation. So there's 6 parts to this. What are these 6 parts? And that's what that question is dealing with, and that's in 7.4.7. What are the 3? Am I supposed to go through each one of these? You're going to read this, right? I assume you're going to go ahead and be like, oh, Brother Chapman, I should totally read this in preparation for my IRAT and TRAT. That's what you're thinking right now, right? I think that's what you're thinking. Or are you thinking, Brother Chapman, can you just tell me on this video because I don't have time to read? Maybe you're thinking that too. I'll let you read it. How about that? What are the 3 ways to check if a distribution follows the exponential distribution? So this is in section 7.4.1. We've talked a little bit about the exponential distribution from chapter 3, forecasting. Specifically, here is the section on exponential distribution. Here's some brief bullets on interesting features. Here's the lambda. Here's the coefficient of variation of 1 for the inter-arrival times. And then down here below this is where it talks about the 3 ways to check to see if a distribution follows the exponential distribution. And it gives an example here. Here's a histogram of the yacht club. And this histogram and this exponential distribution line says it's a reasonably good approximation. Here it is right here. Reasonably good approximation for the inter-arrival times at Michigan Yacht Club. And so that is one of the three. The other two are right here, which directly answers these three ways. Finally, the last bullet, what is the relationship between utilization, variability, and in-buffer inventory? Section 7.5. You want to read both of these sections, get a pretty good understanding of this one. We'll talk about this in our application exercises. There's some basics here if you read 7.5.1, 7.5.2 to help you out. And I hope this is helpful. We'll see you soon.